Homework 12.2, question 6, doing another iterated double integral. Integral from 0 to 1 of the integral from 0 to e to the v of the square root of 1 plus e to the v dw dv. We'll do the inner integral first, the dw one. We really don't have a choice because the inner integral's limits of integrations contain v, so we must do dw first. Starting with the inner integral, integral from 0 to e to the v of the square root of 1 plus e to the v. Now, normally I would write this as a 1/2 power, but we're doing the dw integral first, and this integrand is independent of w. So basically it's constant. So its antiderivative is just w times that constant. So the antiderivative will be w times the square root of 1 plus e to the v. And this is being evaluated from, we did dw, so these are w values. W equals 0 to w equals e to the v. And this is a pretty easy one to evaluate. When we substitute the lower limit, 0, it zeroes out the antiderivative, so we don't have to worry about that. And when we substitute e to the v for the w, it becomes e to the v square root of 1 plus e to the v. So that was pretty easy. And that's a nice thing to have outside that square root, because the second integral from 0 to 1 of e to the v, and now I'm going to rewrite the square root as a 1/2 power. 1 plus e to the v to the 1/2 dv. This one, we really want that e to the v on the outside because now we are doing a u sub, and they just recently reformatted the Zoom whiteboard, so I'm still trying to find things. We're going to let u be the 1 plus e to the v, so that du is equal to e to the v dv. Sorry, that u over here looks a little bit like a v. Let's see if I can make that curvier. There we go. All right, so for my du package, I need, where'd my v go? Mama, I lost my v. There it is. All right, so all this will become du. And so we can just integrate this guy. 1 second. All right, I had to pause for a second. All right, so with our substitution, we end up getting an integral of v equals 0 to v equals 1. And this simply becomes, let's put it back in red, v to the 1/2 power, excuse me, u to the 1/2 power du. And we will integrate and unsubstitute at the same time. Antiderivative is going to have a power of 3/2 with a 2/3 in front. And now we're going to replace the u with what it was representing, which is 1 plus e to the v. And the new power is 3/2. This is evaluated from 0 to 1. Now we can't be so nonchalant about the 0 here because it won't vanish. This is going to be a pretty ugly looking answer. I think I'm going to take it to the next page. Okay, 2/3, 1 plus e to the v to the 3/2 power. And we're going from 0 to 1. When we substitute the 1, we get 2/3, 1 plus e to the 3/2. And when we substitute 0, we get 2/3, 1 plus 0, which of course is 1, to the 3/2. The second part is easy. 1 to the 3/2 is 1. 1 to any power is 1. And so the subtrahend, if you will, the second part of the subtraction problem, or is that the minuend? That's the subtrahend, becomes 2/3. And as far as the minuend, the first part of the subtraction problem, there's not really much we can do besides rewrite it as an exponent, as a radical. So we could write it as 2/3 times the square root of 1 plus e to the 3rd power minus 2/3. We could also do something like, we could do a couple of things. We could factor out the 2/3, and we could square root 2 of the 1 plus e's and get something like 1 plus e, and then the third 1 plus e would remain under the square root. and then -1 because it's factored out of 2/3. Now, my personal preference is I think it's perfectly acceptable. If I can get this to do what I want, I'm still learning where they put all the new tools here. I think it's perfectly acceptable to leave this the way it is. There's some school of thoughts that say, well, if your power, 3, is larger than the index of your radical, square root the index is 2, then that can be simplified because you can square root some of it, but not all of it. Specifically, they're talking about things like, well, we could split this off into the square root of 1 plus e times the square root of 1 plus e squared. And then the square root of 1 plus e squared becomes that, and then the other square root just gets left alone. But in my personal opinion, to say that the part in yellow is not simplified, and then the part in green is simplified, if you ask anybody which of the two expressions looks simpler, the yellow or the green, almost all of them are going to say the yellow. I understand why they call the green one simplified. I did as much of the problem as I could, short of using decimal approximations, by square rooting some but not all of the radicand, square rooting some but not all of the 1 plus e's. But frankly, I think the part in yellow looks a lot better. So any variation of this answer is okay.